LSAT 250 students, I just want to take a moment and go over an example, the final example in your inference to regression analysis. Recall that we were looking at the research question, does the number of species change with an increase in elevation in the Sierra Nevada? Our dependent variable was species richness, is species richness. And this is because this is what we are trying to predict given elevation. The independent variable is elevation. And we are trying to use it to predict species richness. Okay, so moving under that assumption, the first step in doing our regression analysis is to simply import our data. So I'm just copying and pasting this from my notes. I'm going to navigate to my Sierra species file. And what I've done is imported a data frame containing all of the observations in 2 columns. I've attached the data frame, and I've returned the names of the column headings here so we have 1 column named species and 1 column named elevation. The next step is to make a plot of species and elevation. So we're just going to make a plot here of species, elevation, and species. And here's our plot, and we see right off that it doesn't appear to follow a straight line path. It has a curved pattern to it. One of the assumptions of linear regression is that the data forms a linear relationship. So obviously we don't have a linear relationship, but let's go ahead and proceed so that we can see just how bad it is. So the next step here is actually to produce the linear model. And so I'm going to copy from my notes and I'll explain what is going on. I'll walk you through the script. So in the first step here, I'm making an object called lm.diversity, and it's constructing the linear model for the number of species given elevation. Then the next step, the next 2 lines below here are simply going to put in a couple of slopes. Next line here, let me bump this down a notch. This line here is going to plot the AB line representing our model, linear regression model. And then this AB line here is going to plot a horizontal line at the location of the mean. So I've plotted both of those. And so we see here that if you think about the variability here, first it's not a linear fit, so it doesn't bear too much interpretation. But one thing I want you to note especially is that there's a lot of variability from the mean null model and then our constructed linear model here, constructed and in red. So in the next video we're going to take it one to the next step, and we're going to consider transformations that might be appropriate for this type of data.